operator stack we can call it as. We will give an example here. So how this input expression, this is an input expression. So a plus b star c minus d slash e, which is a parenthesized input expression. Can anyone tell me what type of expression it is? It is a, exactly, it is an infix expression because the operators are coming in between the operands. Postfix means operands will come after that operator. Prefix means first operator comes, then operands. Fine. So initially stack is empty. So we have to read every character from this input expression. One by one we have to read, and based on that, if it is a character, we have to add to the resultant reverse polish notation, that is the postfix notation. So since it is an in the first step, it is what we are reading here, it is an operand. So we have to add to the RPN. Stack is empty only. Next plus we will read that. So since plus is an operator, so we are pushing that operator into the stack. Then we are reading the opening parenthesis. So once you read this opening parenthesis, we have to push that opening parenthesis into the stack. Then we are reading the B. So B is an operand, you have to add that operand to the resultant RPN. Then we are reading the next star. So we will compare, since it is an operator, so we will compare that operator precedence with the operator which is having in the topmost. So because it is higher, we will push into the stack. Then we are again getting the opening parenthesis. So opening parenthesis is also pushed into the stack. Then we are getting C. So C is an operand, so you have to add to the RPN. Next we are getting minus. So once you read the minus, so you are going to check. Once you are reading this minus, okay, so you are going to check the topmost operand priority here. Okay, so you are pushing this minus. You are pushing this minus onto the stack. Then we are reading this D. So we are, since operand, we are adding the D to that RPN. Then we are reading the closing parenthesis. So once you are reading the closing parenthesis, so you have to go on remove the topmost elements from the stack until you will get the opening parenthesis. So you will read this and then you will read this opening parenthesis. Opening parenthesis will not be displayed onto this. Just we will ignore that. Then next we will read the slash. So since slash and star, topmost element is star, so both are having equal priority. So we will remove this star and add to this, and then we will push this slash here into the stack. Then we have this next E will be scanned, so E will be added to this. Okay, then closing brace will be scanned here. So once closing brace is scanned, you have to pop up all the operands from this stack. So until you will get a opening parenthesis. So you are going to scan and add to this. So slash will be added, and then this will be also removed. Opening parenthesis is also removed. Then we will see that there are no more operands in this particular. So we will see that is the stack is empty. No, there is a still place is there. So we will add, or we will pop up that place from the stack, and we will add to this RPN resultant expression. So this is what the result of this particular given infix expression is converted into the corresponding postfix expression, which is also called it as reverse polished notation. Fine. So this process is continued until this stack becomes empty. So in the stack, what we are going to store? In the stack, we are going to store only the operators we are going to store. So that is the reason it is an operator stack. Okay, we are not storing the operands, just we are storing the operators we are storing. So it is an operator stack we are calling it as. Fine. So this is how we have converted by taking an example infix expression. Got the point? So this is what the program here. So in this particular program, we are implementing our own stack operation to store these operators. So this is a character stack. top equal to -1, push character we are pushing because operators are again character form. So stack of plus plus top is equal to x, we are pushing that. And this is a pop. If top is equal to -1, we are returning -1, else return stack of top, after that minus minus. So return stack of top minus minus. So this is what we are calling it as a push and pop operations in the stack. And again, there is the function we are writing here to know the priority of the operator. So char c x, if x is equal to opening parenthesis, its priority is return it as 0. So if x is equal to plus or x is equal to minus, both are having equal priority, we are returning priority as 1. If x is equal to star or slash, then we are returning it as 2. Otherwise, we are returning it as 0 again. Fine. So this is what the priorities we are fixing that. And in the main function, we are reading that expression exp of 100 character array. So char star e comma x, enter the expression here scanf percentage s exp. So printf backslash n is equal to exp. So e is a pointer. So while star e not equal to null, so what we are doing here is that, so we are checking all these things, we are checking that. So the process we are going to convert here is star e value is alphanumeric, then printf percentage t star e. Else if star e is equal to opening parenthesis, then we are pushing that star e value into the stack. Else if star e is equal to closing parenthesis, then we are popping this elements from the stack until you are reaching this opening parenthesis, and we are displaying that onto the screen. So else, while priority of stack of element is greater than priority of star of e is greater than priority of star of stack, then printf percentage t, then we are pushing with star. Then e plus plus. So this we are doing that. While top is not equal to -1, then also we are popping all the remaining elements. So we are emptying the stack by making use of this. Fine. So this is what a simple algorithm, simple program here to convert the given infix expression to postfix. So now this is the reflection spot here. So write the equivalent postfix expression for this given infix expression. Okay, so if you are not able to convert this expression, please try to watch this video. So first priority, based on that priority. So first you have to convert this. So postfix expression. So AB plus. Fine. Next you have to convert this DE slash. Over. So this becomes it as 1. And then star F. And this becomes it as 1. And then star C minus. So this is in this, what you will do, this you can take it as some T1 temporary variable substitution, you can do it as, this is nothing but one operand, you can take it as. Okay, the result of this operation, you are going to get it as one operand value. So into C minus, this is nothing but just like this, just you substitute this as T2 into F. So what you are going to do here? So you are going to write here T1 C star and then minus T2 F star. So this becomes it as one operand, entire thing, and this becomes it as another operand. Fine. So this is nothing but what will happen entirely. You can substitute this is as another. So this is, you can take it as T3 value, and then minus this, you can take it as entire thing it as T4. So how we can convert this into postfix expression? So T3, T4 minus. Now you substitute what is the value of T3, what is the value of T4, and substitute what is the value of T1 and what is the value of T2. T2 value is this one. T1 value is this one. you will get the equivalent expression finally in this. Got? So if you are not able to understand, please watch this video from the beginning. So any doubts you have, so this is what LOs are revisited here. After completion of the session, students will able to solve the given infix expression into its equivalent postfix conversion by making use of these stack operations. Fine. So summary of the session is that this infix to postfix conversion is one of the important applications of the stack that we have seen in this particular CDT. Postfix operations, why we are making use of this? Because computers will always use this postfix expression, which is also known it as reverse Polish notation, because it is very easy for the computers to evaluate that expression instead of infix expression. So the computers can simply pass this expression from left to right whenever we are getting that operator, then apply that operator on the topmost two operands from the stack and then store the result back onto the stack. So that we will also see. Thus, we see that in the postfix notation, operators are applied to the operands that are immediately left to them. Fine. So this is what the lecture level practice problem. Convert the following infix expression to postfix expression using the algorithm and show the status of the stack at each step by step you have to show it. Fine. So further readings on this particular topic, you can refer this. So thank you. Thank you very much.